Okay, guys, I'm back for part 2 of Keys to the Kingdom. Now, that's a play on words because part 1 was all about Key Scout. Part 2 is about KeyDiver and some Key Scout thrown in, because what we're going to do in this part is talk about breaking things open. Now, if you don't know what KeyDiver is up on the screen right here, and over on the right-hand side, I've got a detective open. I'm just going to scroll down to the Tools section on the home screen where we have Oxygen Forensic KeyDiver. So you will probably remember Passware built into Detective, some OEM Passware Kit mobile technology where we could throw an iTunes backup in there or an Android backup and work on decrypting those things, or at least getting access to them by dictionary tags and things like that. Now, common question, hey, do you guys decrypt Word documents or other stuff? And the answer was not really, the focus being on mobile. However, KeyDiver has grown up to start hashcatting all kinds of things. And what I mean by hashcat is, let's just use the simple analogy that, hey, I'm going to create a password, and the algorithm used to protect whatever I'm protecting is going to store a hash of that password somewhere inside the document or the file. We know how to find that and compare it against things. So, hey, here's a stored hash of the password. Don't know the password, got to guess against it. Maybe I guess in a key space I can try to brute force all the available keys in an algorithm. Yeah, it's not going to work most of the time. I'll show you why here in a second. So we need good dictionaries to break things open. That's pretty much the name of the game today. Now, here's where Keys to the Kingdom together come into play. And E01s. Let me just not leave that out of it, because the big focus of this conversation is based on some recent functionality in Detective, we can now export word lists from our extractions. What that means is, well, let's think about this, a word list. Where could you get a word list? In my past, I was all about indexing a hard drive with FTK and Access Data. If you could index all the strings on a hard drive, you had one of the best user-defined dictionaries ever. Social engineering, right? I could sit down and take somebody and say, hey, somebody, you know, you're in trouble, so actually you're under arrest, so what's your social security number? And, you know, so I don't have to shoot your dog when it jumps back over the fence and we're sitting here in your front yard. What's your pets' names? And when your kids come home, I want to tell them you're not going to prison forever, so what are their names? What am I gathering from you right now, or this person? Things they use for passwords, right? A user-defined dictionary of socially engineered stuff that people use when they sit down at a computer and are told to protect it, protect something, whether it's your autocomplete data in your browser, you know, hey, it's your bank account login, or because you're lazy, we're human, you know, we store everything. So if we can find those lists, rather than taking every random word in the universe and trying them, let's at least try to focus our effort. All right, let me throw back in time here a little bit. I'm going to open the good old-fashioned key space calculator, and I probably took this thing around the world for 20 years. So much fun. So there's two facets to protecting something. The available key space of the algorithm, so I could have, you know, 52 quadrillion keys, and the entropy of your password, which means, look, you can have the best lock in the world, but if you make a really small number of keys for it, you don't really have to try a whole lot. So if your password's 2 characters long, you know, that's not good. If your password's 40 characters long, all random and not, you know, one word that's known from a dictionary, now you're talking. But let's just talk about key space for a minute to illustrate a problem. So if my algorithm is 2 bits, right? Well, 2 bits gives you a potential of 4 keys. And if my computer guesses 250,000 guesses per second, well, guess what? One machine is going to, it doesn't even blink, and it gets that done. Well, let's just take a massive leap in time. I mean, we can play the game. Hey, what does an 8-bit system look like? Well, we got 256 keys, 250,000 guesses a second, one machine. Yeah, anyway. Okay, what about a 16-bit system? Because every time we add a bit, the number of choices doubles. And you can go all the way back to, oh, FAT16 could keep track of 65,536 things, right? 0 to 65, 535. Well, hey, one computer can still guess through that at 250,000 guesses a second in no time. So let's jump up to 40-bit encryption, where we have, oh wow, now we're talking. Now we got a 1,099,511,000,000 and some odd change. Well, hey, one computer guessing 250,000 guesses a second, you know, can do that in about, what, 50 days. Okay, Now, that's completely unrealistic today. I mean, let's say your machine's guessing 1,000,000 guesses per second against the derivation of that key. You know, technology is a lot faster. Moore's law, whatever you want to say. Look, we could guess through, if you had the best possible password ever, all the keys that could be generated by that best possible password, we could still get through it in 12.7 days. Okay, we're not at 40-bit anymore. Let's say, now watch this. There are 2,048-bit algorithms out there. I'm going to throw down a 256-bit algorithm. And wow, okay, we just went off the chart, right? This number just says die human. I mean, you're never going to... Okay, wait, I know what you're saying. Well, Keith, you only got one machine. You're right. Let's do 50 machines, guessing 1,000,000 guesses a second. Yeah, and so? You're like, but no, technology is really great. You know, I agree with you. Let's add, I don't know, a couple more zeros on there. And let's just say we have all the computers in the country, 5 million computers guessing 100 million guesses a second. Not a change. I mean, good luck with that. Okay, let's say we've got DNA with all the computers around the world, and they are supercomputers like crazy from planet Krypton, and so we are not going to get through that key space. If you see where I'm hovering over that cell, that's probably more grains of sand than all the beaches in the universe. I don't know. Any good chat GPT answer will tell you you're not getting through the number of keys. You can't brute force all these keys with technology we have today. So what do we need? The password, right? So let's think about if I take a password and I provide it to whatever I'm protecting and it says, oh, great, I'm going to take that password, do some things to it, hash it up and store the hash somewhere. So when you come back later and put your password back in the box, I can do what I do to it and make sure it matches what's stored, and I'll give you access to that. So this comes back to we need good dictionaries, right? We need good dictionaries to go after things. Now, again, where do we get those dictionaries? Let me just pop open Detective here real quick. I've got one extraction in here. And this is a PC, by the way. This is an E01. And I bring that up. Again, there are tons of E01s laying around out there in storage. You know, not cold storage or old cases. Maybe you're working on them now and you need another way to generate a word list because maybe you're trying to break something open. Okay, accounts and passwords, you all would recognize accounts and passwords from Detective already, saying, hey, we got a phone extraction or anything we can do. We always go after whatever accounts and passwords and tokens we can display. But that's from known locations and known applications, not word lists from things like message content or browser search histories or things like that are, hey, 5 will get you 10. You know, things you're searching for on the internet are things you like and may very well possibly be passwords. Okay? Now, here's the thing. So I'm just going to, actually, let's get rid of this. I will remove this extraction out of here. And in Detective, I'm going to use the option to load a Windows, Mac, or Linux physical image. And you can see E01 is one of those options. Because when I do that, one of the keys to the kingdom comes into play. KeyScout pops up. And you can see I've already been here to find this E01 file, because it's going to load through KeyScout. So let me open that and click Next. And it's going to say, what operating system is this, just to help me be clear on that. And I'll pick Windows. And I'm just going to go ahead and pick Applications, System Artifacts, Passwords, and Tokens by default paths. But if we were going to create a profile, here's where this gets really interesting. Look at all the applications that are supported. Matter of fact, I can just sort by Windows since we're playing a Windows game right now and apply that. And any of the content and any of the cool stuff we can find from these Windows applications might very well give us word list content, right? So I'll cancel that. I'm going to take the default for everything, and I'll start a search. I'm just going to let it go against this E01. I can hyperspeed us through the process here, but you can already see, oh, look, DuckDuckGo, Google Chrome, Microsoft Edge, Discord, Signal, you know, phone link. It's just going to town, finding all kinds of things. And then we're going to pull this into Detective to recreate what I just deleted a second ago. But this key to the kingdom allows us to go grab E01s we have laying anywhere and pull them in like this. So I'll get them in Detective, and then we're going to see what it looks like to export that word list and give it to KeyDiver to use as a dictionary. Find out how that becomes super valuable to us. Okay, let's open this thing up And it looks like the one I just got rid of a minute ago. And here, watch this, I can right-click and create a word list from words and numbers. So this little, I'm going to call it an algorithmic script type thing, goes through and it says, okay, listen, what applications do you want to export data from? And I'm going to pick all of them just to see what we get here. Do you want to limit your word length in any particular fashion? 2 and 255, that's fair. So that's saying, hey, find me strings separated by non-word characters like spaces, things like that. So let's save that. And I'm just going to call it on my desktop, well, that's a long name. How about Keys to Kingdom Word List, ktkw.txt. And I'll save that out to my desktop there. And I'll tell you this, I'm going to cheat and show you something. So here in Chrome, I actually went out and searched for, yes, this is me doing this. I searched for Klingon and Gowron, who's a Klingon. If you have any Star Trek lore inside of you, or you know me and my affinity for science fiction. So those are some keywords searched on the internet. Like I said earlier, look, 5 will get you 10 things I search for, I'm interested in, and could very well be a password. So good enough on that. I'll minimize detective out of the way. I've already got KeyScout done, so I'll minimize that. And then I've got KeyDiver up here waiting on me. Now, I've also got an encrypted Word document up here. So let's look at KeyDiver for this other key to the kingdom. Just a quick rundown, and hey, pay attention in 2026. We're going to build some KeyDiver, let's break into things training, dedicated to how to use this and get those great dictionaries and get into things we can't get into. So there's some efficiency settings, temperature thresholds that tell the machine to back off a little bit. Hey, queue management for things, recovery rates, dictionary management, enables CPUs or selections or GPUs and things like that. And this is pretty cool because not only can we do GPU, we can do CPU. And sometimes, technologies don't incorporate both like that. So this is a good thing. We have a dashboard here of in-progress jobs in the queue, pause, successful, errors, or fails. Create new attacks. I just got some things in here from playing around before. We can also look at different columns we'd like to see in our dashboard here. I'm just going to create a new attack, and let's look at how this works. So to create a new attack, upload an attack settings file or select a supported object type from the list. Let's look at the list. So zip, NTLM, 1Password, PDF, 7-zip, Huawei, Telegram, BitLocker, Android, FileVault, all kinds of fun stuff as this continues to, it's like watching Cloud Extractor have, updates or Detective have new features. I'm always looking for KeyDiver to have new things in the list to go attack. So I'm just going to pick Word, and it says, okay, when creating a document, the user could set a password. The password can be brute forced by extracting the encryption information, which means let's load this encrypted Word document I have sitting on my desktop. And Hashcat goes out and finds the stored value it wants to compare against. So I'll click Next. And here we go. How are we going to attack this? Well, I want to select method. I'm not doing a template right now. Do I want to make a mask, which allows you to do all kinds of brute force switcheroos and different ways to variations of combinations and everything to brute force all the potential combinations? Do I want to use a dictionary or an extraction-based dictionary? And this is just taking the passwords and account list from any of our extractions in Detective. But no, we're going to do this one right now, a straight-up dictionary. This method involves trying passwords from a downloaded directory which can be compiled by the user or found in the relevant resources. And relevant resources is a super key word right there, because now that we can pull a word list from an E01, somebody's hard drive, that is a relevant resource. That's like sitting down and writing down the social engineer dictionary list, or going out to the internet and getting RockU, which is like, 100,000 or 10,000 of the most common passwords in the universe that are always used, or whatever it is. Wherever you can get good dictionaries to guess with, better for you. So I'm going to pick dictionary here. And it says select dictionary. Well, my list right now is the 100,000 most popular, comes by default in the tool, all kind of variations of pins, right? 4 to 5, 4 to 9, 4, 4, 6, 4, 5, 6. Just, hey, if you're using a phone and you got to put in a 6-digit pin, what are all the combinations there? Let's go through them. Or previously acquired passwords. Call that the golden dictionary in my old life. I'll call it the golden dictionary here too. Hey, if I recover a password, that is a golden nugget of information. You know why? because people use the same passwords over and over. I work here. I worked at Access Data with Password Recovery Toolkit and distributed network attack technology, and I still use the same passwords. I'm human. We all do it. So if you can recover one, chances are it will break into other things. So we're going to keep track of those. But in this case, I'm going to add a new dictionary because I'm going to use the one we just made, KTKW. I'll open that. It's in there. Terrific. So in my list, let me make sure I pick it. There we go. And I'll click Next. You can see there's 14,625 strings in here. Things to guess in our list. Well, I actually want to have some demonstrative showcasing of KeyDiver here. So let me go back. I'm actually going to add in here the most popular 100,000. So now we're up to 100,014,625. So I've got both of those dictionaries selected. And I'll click Next now. What do I want to do here? And there's a lot of functionality involved in how far you want to take this, but I could add suffixes to the word, prefixes to the word. You know, I can change character order around. I can skip characters. I can use upper, lower case. I mean, you can use all kinds of permutations of these dictionaries to replicate what the human was thinking, right? So I'm sitting at the keyboard, and 25 years ago, I was asked, "Hey, give me a password." Well, my pet's name's R2D2. Nobody's ever going to guess that, even though Star Wars was like super popular, and probably everybody's pet's names was R2D2. Nobody guessed that. So I put it in, and of course somebody guesses that. So the next time it says, "Hey, I need a password," like, well, I got burned by R2D2 back in the day, so I'm going to put the last 4 digits of my phone number in. Nobody's going to guess that because they wouldn't even think that. Well, of course they do. So the next time I put R2D2 and the last 4 digits of my phone number together, because nobody would ever come up with that. Of course they come up with that. You see what I'm saying here? We are trying to replicate what the human's thinking, so we have all kinds of different parameters we can apply to even the simplest list. Think of that social engineering example I just gave you. What's your pet's name? What's your social security number? What's your kids' names? What's your phone number? What's your address? Things that are right at the tip of everybody's tongue when they need a password on the spot. And then we can take those and mix and match them together. I mean, man, our tools help us become better breakers of things. Like I would say, let me help my technology help me, help us both become a better investigative team. This works with this kind of stuff too. So right now I'm not going to pick any of this because it would exponentially increase my time to do things. So I'll just click Next. And here I get to say, okay, how do you want to go about this? Throw down as hard as your computer can do it, or just average. And what temperature, you got to start at 60 degrees Celsius is the minimum you can make the threshold. I don't think we'll hit that during this, but I'm going to leave it at 60. And I'm going to pick, I'll use my Intel GPU, I'll use my NVIDIA stuff, I'll use my Intel CPU, and then I think the NVIDIA's listed twice because of a driver update, I think. I'll pick it all. I'm just going to go hog wild and pick every resource I have. Okay, let's start that and see what happens. Now, I am a crazy addict of watching speed, things go fast, so I'm just going to come here and I'm going to watch, I'll watch right here. So here we go. I'm looking at the Intel graphics card. And the attack, so what KeyDiver is doing in the background, saying, okay, out of these 114,000 passwords, you picked a Word document. Okay, I got to do this to each one to try to match that hash. Let's see. Okay, figuring out what it's doing essentially, and you'll watch in a second. It's going to take off guessing and formulating all the derivations that it has to formulate to make the guess against what's stored in that file. Oh, and there we go. So my attack is in progress. My CPU or GPU is at 53 degrees Celsius. Wow, look at that. This is what I love to see. I mean, don't waste a cycle type thing. So I've got the Intel GPUs kicked off right here. The NVIDIA's not even being touched right now. What's the CPU doing? Hey, I got a bunch of cores, mid-range in it. I picked average, so that's about fair, but I love watching that right there. That's crazy. Oh, we're kicking up to 55. Okay, this ought to be interesting. We're at 3%. Now I got some passwords checked here. Oh, wow, 44%. Got passwords checked. Got time elapsed and remaining. Ooh, it's the waiting game. Oh, 56. %, 86,000 passwords checked, 19 seconds remaining. Oh, look at that. 100,000 passwords checked, 10 seconds remaining, and Klingon is the password. Now, you might recall that was one of the search terms. Now look at everything dropping off back to normal over here. That was one of the search terms in our word list. Let's just check in there. I will go in here and let's do a Control F for Klingon. Oh, and there it is. Matter of fact, I think there might be a couple examples. There's an uppercase K and 3D Klingon. Yeah, but certainly the Klingon I was looking for is right there. Okay, let's recap what we just did. In a Keys to the Kingdom conversation, I used Key Scout to open an existing E01 to generate a word list through Detective from the parsed apps from Key Scout against the E01. I gave that word list to KeyDiver as a dictionary to attack a targeted file because, listen, the target of my attack here is a Star Trek fan. No, I don't know. In this case, look, all the intel I can give the tool, the KeyDiver tool, to guess against this encryption, I mean, the better. The better dictionary I have, the better chances I have of success, because we're not going to exhaust some of those massive key spaces. Again, you could have the most killer lock in the world with the most voluminous number of keys ever available, but if you have a 3-character password, you're not doing yourself any good. You know, or if you have a known word, 100,000 of the best known passwords, you know, password 123 or Klingon, or, you know, what would have been better would have been %_ upside down character Klingon 1296842 HJQLM. I mean, some fractal password from Hades would be the way to do that. But in this case, we were able to use a couple of keys to the kingdom together to get a super killer word list to break something open. There you go. Happy oxygen technologying. I will catch you later.